There was an attempt to communicate with us before we had radio waves, and they concluded that there's no sign of intelligent life on Earth. Suppose, not only that, they figured out a cleverer way to communicate than radio waves and radio television, a way that we have yet to invent.
The idea that humans are not alone in this universe has been around ever since we first gazed up at the stars and wondered what was out there. In a massive study completed in the last few years, astronomers found that there may be at least 36 alien civilizations within the Milky Way galaxy alone. The Milky Way is home to billions of stars, many of them with the power to support its own planetary system. Though we've come a long way as a species in our knowledge of the cosmos, there are still so many unanswered questions about the possibility of intelligent extraterrestrial life. We may not even be able to recognize alien life, especially if their technology far surpasses our own capabilities. How many alien civilizations could really be out there? And if there are, how much more advanced could they be than our own? While we have not yet been able to prove that these advanced alien civilizations exist, astronomers may have stumbled upon a new trove of potential evidence, a star that may be used as an alien dump site. In 1961, the Polish-American astronomer Antoni Przybylski discovered the most unusual star he had ever seen. This star would come to be known as the Przybylski star. It is a blue star around 3.8 times larger than the mass of our Sun and is located around 355 light-years from Earth within the constellation of Centaurus in the southern skies. He noted that the spectrum produced by the star is unlike anything he had previously seen and would not match any of the spectral categories already attributed to stars. These spectrums show what elements are present within the star and can be seen by splitting the light from a star into its spectral lines. Each element and molecule within a star will give off a particular wavelength corresponding to that only of a molecule or element. So, by breaking the light from the star down into its spectral lines, astronomers can find out what elements are present within a particular star in order to classify it along with other stars. When Przybylski recorded the spectrum for this unique star, he found it interesting because it contains many exotic elements that he did not expect to see inside a star. But this was not the only feature of the star that has intrigued scientists in Przybylski. Astronomers noticed that in addition to its unusual elements, the star also exhibited some unusual movements. The Przybylski star rotates very slowly. One full rotation about its vertical axis takes nearly 200 years, which is an extremely long amount of time for a star to make one full rotation on its axis. To compare this rotational period to our Sun's, it only takes our Sun about 27 days to complete one full rotation. This star baffled him and continues to interest other astronomers even today. They still cannot figure out how this star was able to contain all these unusual elements. To this day, there is still not a well-accepted theory as to how Przybylski's star came to contain them. The elements that were found in the spectrum of the star are considered to be rare elements on Earth. These include europium, terbium, holmium, and gadolinium, along with unusually low amounts of the metals iron and nickel, which are often found inside stars. In addition to those elements, this star also contains some of the super heavy metals known as actinides, like plutonium, curium, and americanium. Actinides are found below the periodic table in their own group that starts with the element actinium. These elements all share their highly reactive nature. Many of these elements found in Przybylski's star are not stable enough to exist on Earth. As well, some of these elements are thought to not exist naturally at all, and when these elements are made in the lab on Earth, they are only able to be detected by our instruments but not really be seen by scientists because they may exist for fractions of a second before they decay. When studying stars, astronomers do not expect to find heavy elements like this in a star because we have never found a star that contains them, and they shouldn't be stable enough to exist within the scorching interior of a star. This has led to some interesting theories regarding the reasons for the elements being there. These theories include theoretical isotopes of unstable elements that exist on an island of stability, a neutron star, spewing heavy metals into space around the Przybylski star, and a possibility for a site that an alien civilization uses to dump their nuclear waste. First, let's take a closer look at this so-called island of stability. The heavier elements towards the end of the periodic table are not very stable in their ground state. They have very short half-lives, which leads these elements to decay into lesser elements in a very short amount of time. But nuclear scientists believe that there exist isotopes of some of these super heavy elements that make them much more stable. This stability in turn increases their half-life significantly. The production of these isotopes exists outside of the current experimental abilities, so they remain somewhat theoretical at this point. But studies have found an island of stability within a chart of nucleides' half-lives. This island of stability predicts that the super-heavy elements with at least 114 protons may have stable isotopes. Astronomers believe that these theoretical isotopes that exist in the island of stability exist in Cybelsky star, and the heavy elements that we were detecting are the remnants of the decay of the more stable isotopes. In order to confirm this theory, scientists will first need to find a way to synthesize these stable isotopes of the super-heavy elements in a lab so that they can be studied. Another theory posits that these odd elements could have been fed to the Cybelsky star by a nearby neutron star. A neutron star is one of the densest objects in the universe and could theoretically contain and spew out elements like strontium and einsteinium. The theory goes out that once these heavy elements are spewed out from the neutron star, they could then in turn be drawn into the Cybelsky star where they burn up and show up in the star's spectral analysis. The only problem with this theory is that neutron stars are relatively rare in the universe, and as hard as astronomers have tried, they have yet to find a neutron star nearby. Don't discount this theory because of that though. It may still be correct and astronomers just have not found the neutron star yet, or they may not be able to detect the neutron star for some unknown reason. One of the more imaginative and exciting theories that have been put forth by a few individuals includes the work of extraterrestrial beings. This theory states that this star is being used by an alien civilization as a dump site for some of their nuclear waste. An alien civilization who has more advanced technologies may be utilizing an energy source that we don't even know of yet. Theoretically, all of the elements that are found in Cybelsky star could have been the byproduct of nuclear fusion that aliens may use as an energy source to power their planet. It may not be as crazy as it seems. There have been multiple scientists in nuclear physics who supported the idea of sending the nuclear waste that we create into the sun for its disposal, although this has never been done. As of now, only a small fraction of the cosmos has been explored by humans, and there is so much more out there waiting to be found. And as long as there are new things to discover in our universe, scientists will continue to explore and discover. It is inevitable that they will find incredible objects that seem to defy our current understanding of nature, and it'll be up to them to think of new theories to explain these events and connect them to what we know about the nature of the universe. Of the three theories we covered in the video, which do you think is the closest to the actual truth? Or do you have a different theory of your own that might be able to explain why the Cybelsky star contains so many exotic elements? Join us next time to discover more things about our universe. If you watched all the way to the end, we want to say thank you for watching, and if you enjoyed this video, please feel free to hit the like and subscribe button so you won't miss any of our future videos.
Have you ever thought about how lucky we are with the placement of our planet that we live on? The Earth is within a range of the sun that we don't get too much of the harmful radiation from it, but close enough that it keeps our planet warm enough for life to flourish. But most of the planets that astronomers have discovered out in outer space are, unlike our planet, inhospitable and devoid of life as we know it. They have discovered planets made of solid ice, and these types of planets are not very rare here because the vast majority of space is a cold vacuum. Astronomers have also found planets made of solid diamonds and others that are full of toxic chemicals. There is also a type of planet that has been found that are berthed very close to their stars. This close proximity to a massive hot ball of plasma makes the surfaces of these planets oppressively hot. One planet that was recently discovered orbiting a giant star is called Kelt 9. Kelt 9 is a star that is over 2 times larger than our own sun and burns almost twice as hot. It is a blue star that burns hotter than 10,000 degrees Kelvin, which is over 17,000 degrees Fahrenheit, while our sun only burns around 10,000 degrees Fahrenheit at its hottest. This star is also still relatively young within the timescale of stars. It is only 300 million years old and has much more of its life remaining. But the features of Kelt 9 are not what interests astronomers the most about this star. That interest is directed toward one of the planets that orbits it. Using the Kilodegree Extremely Little Telescope, which is also known as KELT, astronomers found the planet now known as Kelt 9b. They detected this planet by measuring the amount of light the star was giving out and noticed a small dimming effect in the light as a planet moved in front of it. This star and planet are about 670 light years away. Isn't it incredible that astronomers can pick up on such a small change from that great a distance using today's telescopes? Kelt 9b is a gas giant like Jupiter. This planet is almost 2.8 times bigger than Jupiter, but only half as dense, which makes Kelt 9b a massive gas giant. But its size, density, and its makeup is not what made astronomers interested in Kelt 9b at first. It orbits its star extremely closely, making the surface of the planet hotter than the majority of stars in our universe. Kelt 9b orbits its star closely and quickly, with 1 year only lasting 36 hours. This means that it experiences all 4 seasons in that short time, making each season last for only 9 hours. Down on the surface, Kelt 9b is extremely hot. It can reach daytime temperatures around 4,600 degrees Kelvin, which is equal to 7,800 degrees Fahrenheit. To put that into perspective, the coolest stars only burn at 2,500 degrees Kelvin, which is just over 4,000 degrees Fahrenheit. When astronomers compared the surface temperatures to the stars in the observable universe, they found that Kelt 9b is hotter than 80% of all the stars. Our Sun is one of those 20% of stars that burn hotter than Kelt 9b, with its temperature soaring to over 5,750 degrees Kelvin, which is nearly 10,000 degrees Fahrenheit. But how can a planet be hotter than the majority of stars in our universe? And what has caused this planet to grow to be this incredibly hot? It turns out that astronomers found that there are a few reasons for Kelt 9b's sweltering surface temperatures. One of these reasons for the scorching daytime temperatures is purely based on the distance that it orbits its star. Think about the planet closest to our Sun, Mercury, which is one of the hottest planets in our solar system purely because of its proximity to our Sun. With its daytime temperature maxing out at almost 8 times the hottest temperatures we have measured on Earth. The surface on Mercury can reach temperatures of over 800 degrees Fahrenheit, which is still extremely hot even if it's much cooler than Kelt 9b. But Kelt 9b orbits its star much closer than Mercury does. In fact, it orbits 10 times closer. This means that Kelt 9b is being blasted with light from its star constantly. This light strikes the surface and heats up its atmosphere to a great degree. But if those are the only factors that are causing this planet to heat up, the surface would not reach the temperatures that it does. So there must be something else that contributes to the extreme temperatures that astronomers see on Kelt 9b. Not only does Kelt 9b orbit extremely close to its star, it also is locked in a tidal orbit with it. An object in a tidal orbit will rotate at a rate so that as it orbits around the star, the side that faces the star is always the same. This is the same type of orbit that our moon has with the Earth. If you look at the moon on a clear night, you will always see the same side of it. This means that Kelt 9b has a side of it that is permanently day and a side of the planet that is permanently night. The daytime side of the planet is receiving all of the heat from the star without having a break to dissipate some of that heat out into space. But there is one other factor that adds to hot temperatures on the surface. Kelt 9 is a star larger than our Sun, and similarly to our Sun, it doesn't only emit visible light. There are other forms of light that this star produces in the form of radiation that Kelt 9b is exposed to. Like all stars in our universe, Kelt 9 undergoes nuclear fusion in its core, producing enormous amounts of energy and blasting light out in all directions around it. This light includes many different wavelengths, including visible and ultraviolet light. So not only is Kelt 9 being bombarded with heat from its star, but it also is getting blasted with ultraviolet light. It is this ultraviolet, or UV light, that causes this gaseous giant to increase in heat even more and is slowly evaporating the surface. Astronomers were able to discover all of this information about Kelt 9b and what makes it so hot using data gathered from the shadow as it orbits around its star. The instruments that they are using now were not built with the intent to study the atmosphere and properties of different planets in the universe, but tools that are more tuned for this use have been in the minds of scientists for some time. And as the hunt for more exoplanets and the need to know more about them grows, new instruments that can probe deeper into these planets will be built. Extreme planets exist out in the cosmos, and trying to find and identify as many as possible is the dream of many astronomers. As they delve deeper into the corner of our universe, astronomers keep finding objects that are more unbelievable than the last. The more that we learn about the universe, the more it shows us that there is still much more out there yet to be discovered, and that we can't always predict what is going to be found. Join us again to discover more marvelous things about the universe all around. If you watched all the way to the end, we want to say thank you for watching. And if you enjoyed this video, please feel free to hit the like and subscribe buttons so you won't miss any of our future videos.
There's something mysterious lurking in the depths of space. It's massive, yet formless, and it threatens to destroy everything in its path. Close encounters with it don't end well, as this powerful entity has the capacity to rip apart all that it comes in contact with. While we know so much more than we once did about what lies beyond our solar system, outer space continues to contain extraordinary mysteries of the unknown. It's endlessly fascinating and sometimes even terrifying. When we peer through the looking glass and investigate what's out there, the potential for destruction is almost unimaginable, and astronomers are still seeking to understand what's behind these destructive forces and what possible impact they could have on us. What has been going on in space? Throughout the cosmos, there have been evidence of some kind of powerful destructive force out there. Astronomers have seen stars being destroyed and disappearing from the night sky. There are remnants of galaxies floating about, isolated in space, while other galaxies are shifting and some are even colliding with each other. What could be out there that has the power to destroy stars and manipulate galaxies? It must be something insanely strong that causes these massive cosmic disturbances. What could have caused this? Cosmic bodies like stars are rather large and do not typically disappear without a trace. Because they're so enormous, whatever is causing all these events to happen must be extremely massive in order to affect other objects of this size. Astronomers do not always get to see the stars as they disappear. Scientists usually just observe the empty space where the star used to reside. With this knowledge, they know that whatever is causing the destruction must also be very hard to detect. Scientists use a variety of instruments to probe out and detect things happening in space, and many of them cannot be used to find these star destroyers. Throughout all of physics, there is only one object that could be destroying stars and other objects of this size. Scientists know that it must be a black hole. What is a black hole? Black holes were once thought to be nothing but science fiction after Albert Einstein first theorized their existence in his theory of general relativity in the year 1916. It would take another 55 years until 1971 for the first black hole to be detected in our universe. Black holes are born from the matter of dying stars. When a star with a sufficient mass begins to die, a black hole may be born in two ways. First, the star can explode in a massive explosion called a supernova. As it explodes, the star's core will begin to collapse in on itself, creating an incredibly dense ball in the center. This dense ball continues to draw in more mass and collapse further in on itself until it becomes dense enough to form a black hole. Black holes have an unparalleled gravitational force that will draw in anything that is unlucky enough to get in close. The other way a black hole can form in the dying throes of a star circumvents a supernova altogether. If the core begins to collapse in on itself before the supernova takes place, it can produce a gravitational force strong enough to overcome the explosive outward force. When this happens, a black hole is born without any of the usual fanfare astronomers see in a supernova. These types of black holes are much harder to detect when they are born because there is no supernova cloud or outburst of energy. A star in the sky just goes dark as it forms a new black hole. Astronomers typically detect black holes by using telescopes with X-ray capabilities and using it to scan the cosmos for a specific X-ray signature. This X-ray signature is picking up the emitted X-rays that are being produced by the yet-to-be-devoured, superheated gas and matter that swirl around and into the black hole. Searching for the emit X-rays from these clouds around the black hole are one of the most reliable way that astronomers have found to detect black holes from the Earth. How does a black hole destroy an object as big as a star? When there is a cloud of matter swirling into the black hole, it is feeding, and this is one of the most fascinating processes in our universe. Astronomers can only see what is around the black hole and the boundary of the black hole. This boundary is called the event horizon and marks the point at which not even light can escape the gravitational pull and is drawn into the black hole. Once matter or light passes this point, it becomes part of the black hole itself. The gravitational pull grows so strong as something approaches the event horizon of the black hole that the end closest to the black hole gets pulled stronger than the far end, leading to a process scientists called spaghettification. This process causes objects to elongate and be pulled longer and longer, resembling a piece of spaghetti as it is sucked beyond the event horizon and into the black hole's interior. NASA recently was able to capture images of a black hole actively feeding on a star. This spectacular event was captured by the Transiting Exoplanet Survey Satellite, or TESS. This allowed astronomers for the first time to watch a black hole tear apart a star and draw it into itself. This particular black hole resides around the Volans constellation, roughly 375 million light-years away from Earth. How big can black holes get? As black holes feed, their mass becomes larger in addition to growing in size. Black holes range in size and can be relatively small, but they can also become monstrously massive. The smallest black holes that astronomers have found measure only 3.8 times the mass of our Sun, which is quite a bit smaller than some stars that scientists have found. But the biggest black hole astronomers have found is many billions of times larger than our Sun, and some believe that black holes can grow to sizes as large as 100 billion solar masses. The biggest black hole that has been found alone is almost unthinkably large at 66 billion times the mass of our Sun. It is so large that if it were to be placed in the center of our solar system, it would stretch out past the outer limits of the system. A black hole big enough to eat a galaxy. What are the implications of a giant supermassive black hole of this size? What could they be capable of? Astronomers have already theorized that a supermassive black hole in the center of a galaxy with enough gravitational pull could lead to the death of its own home. When black holes feed, they draw in giant clouds of gas and other matter. But not all forms of this matter get pulled into the black hole. Some of it forms an orbiting cloud around the black hole called an accretion disk. The matter in these accretion disks gets so hot that it begins to radiate energy out in the form of light, including visible light and X-ray radiation. This outpour of energy can be strong enough to rip apart the galaxy it resides in, destroying everything around it. Then this supermassive black hole is then left on its own, isolated in the depths of space. A supermassive black hole of this size would be one of the most destructive objects that is theoretically out there, somewhere in the universe. Black holes flying through the cosmos. The size of black holes are not the only frightening realities of black holes, though. Did you know that they can travel through space on their own, devouring everything in their path? These types of black holes are called rogue black holes, and the cosmos may be filled with them, flying through space at dizzying speeds. The average rogue black hole travels well over 100,000 miles an hour, but at least one has been clocked going nearly 5 million miles an hour. That means it's covering over 1,300 miles every second. Astronomers believe that supermassive black holes can become rogue when two galaxies, each with a supermassive black hole, collide, and in the ensuing chaos, one of the supermassive black holes is thrown out of its galaxy and barrels through the cosmos on its own. Once a black hole goes rogue, there is very little that can stop it from destroying everything that is unlucky enough to get trapped in its immense gravitational pull. Black holes are one of the most destructive objects in our universe, and astronomers still do not understand everything about them. Who knows what we will learn when astronomers can take a closer look into black holes. There are many frightening and mysterious objects that lay beyond our solar system, and black holes are just one of them. Scientists will keep striving to understand more about our universe to keep us more informed and better prepared for what might be found out in the deep cosmos. Thank you for watching, and if you enjoyed this video, Please feel free to hit the like and subscribe button so you won't miss any of our future videos. Our universe is full of crazy, unexpected objects and events that make it such an amazing place to explore. So many of the discoveries made in space are unexpected. Some of them are incredibly interesting while being beautiful and benign. But there are others that are extremely violent and destructive. Astronomers' jobs are to study what happens in the cosmos and try to explain what is happening and to predict events happening in the future so that they can take a closer look. Whether these events have an impact on Earth or not, understanding them more will lead astronomers to a deeper understanding of our universe. Asteroid impacts. One of the first examples of a cosmic event that humans experience were asteroid impacts. Astronomers have found that our own solar system has a large asteroid belt within it. This belt sits between Jupiter and Mars and contains over 700,000 individual asteroids in the main section of the belt. If an asteroid were to be hurled from the belt in the direction of Earth, a large enough impact will cause a lot of change to life on our planet. Like when an asteroid impact brought the age of dinosaurs to an end. The damage from the impact would be enormous, but it wouldn't be the only form of disaster due to the asteroid. An impact big enough could send enough dust and soot into our atmosphere that the sun could be blackened out for years. If Earth is struck with an asteroid impact, we can all expect life on this planet to change drastically in its aftermath. Radio signals from deep space. Some discoveries that astronomers make have no simple answer as to what they are. The instruments that we use to learn about our universe give us data that has to be interpreted in order to ascertain what it is showing us. One type of information that gets transmitted throughout the galaxy are radio waves. Radio waves are a type of light wave that can travel vast distances through the vacuum of space and can be picked up by our instruments and can tell us a lot about what produced the signal and where it comes from. But sometimes, scientists cannot figure out the origin of a signal and need to test new theories to understand what is happening. Astronomers using telescopes like Hubble have discovered over 1,000 fast radio burst signals, FRBs, coming from deep space since the first discovery of one in 2001. These signals are extremely powerful pulses of radio waves that can last for only fractions of a second, and scientists still do not know what causes them. The majority of the signals that have been detected only came through once, but some signals have been known to be picked up again and again, most of the time without a recognizable pattern. However, a telescope in Canada has recently found a fast radio burst that repeats on a regular cycle that takes about 16 days. This type of repeating pattern intrigues astronomers because they believe that they can use the pattern to help understand what is producing these bursts. Strange signals from the Milky Way. These strange signals are not only coming from deep space. Astronomers have also found these signals coming from sources within our own galaxy. In 2020, two separate radio telescopes on the ground detected an extremely intense pulse of radio waves. These radio pulses were classified as FRBs. Scientists don't know what or how fast radio bursts are created, but they know it must have a high energy source. They were able to trace back these radio bursts from a general area in space that is only 30,000 light years from Earth. This makes this FRB the closest one to Earth ever discovered. Astronomers still do not know what produces these fast radio bursts, but some evidence has come out in recent years that point towards a few new theories. One of the most promising theories that came along the detection of FRBs from the Milky Way points towards young neutron stars being a possible source. Neutron stars are the remnants of massive stars that went supernova but did not condense their mass enough to form a black hole in the aftermath. But until they can get more data and better instruments, their origins will still be a mystery. Rogue planets. Ever since scientists began to probe outer space with high-powered rockets and telescopes, they have been looking for other signs of habitable planets. They look for planets that are close enough to their star to be warm, as well as other features that may sustain life. Although, astronomers have found a lot of planets that could be considered habitable. They have also found many more that do not fit the description. One type of planet that is definitely not hospitable are rogue planets. Astronomers have recently found planets that are not orbiting a star at all and are drifting through the cosmos on their own. The vast majority of planets astronomers have discovered are in orbit around a star. But these rogue planets have been ejected from the star system they were born in, destined to drift through the cold vacuum of space. No one knows what caused these planets to eject, but some theories posited included asteroid impacts with enough force to dislodge them from orbit. Another theory as to how rogue planets come about is that after their birth orbiting a star, another celestial body like a star comes close enough that its gravity pulls the planet out of its orbit and into space. Regardless of how they became rogue, once they are on their own, they will drift in the cold vacuum of space. Rogue black holes. The discovery of black holes changed the way we look at the universe, knowing that there are massively dense objects out there with gravitational pulls so strong that not even light can escape. But as astronomers sought out more information about black holes, they made some discoveries that shock them even more. They know that many galaxies have massive black holes in the center of them, and that smaller black holes are not extremely rare within the greater universe. But one discovery that they did not anticipate is that black holes do not always stay in place. Rogue black holes have been discovered flying through space at mind-boggling speeds. These monsters can fly through space, devouring anything unlucky enough to be in its path. Astronomers believe that black holes can become rogue black holes after being ejected from whatever galaxy they were born in. This could happen as the result of two galaxies colliding with each other, flinging their contents into empty space. If a black hole gets ejected, the rogue black holes will barrel through space, and there isn't much that could stop it. Galactic cannibalism. Did you know that galaxies can eat each other? When two galaxies come close enough to each other, the larger galaxy's gravitational force will begin to draw the smaller one in. This will start the process of two galaxies merging into one, in an extremely violent event called galactic cannibalism, where two galaxies become one. Both galaxies will begin to accelerate towards each other, and as they begin to continue, they will begin spinning around each other while stars from both of them are ripped free and flung out into the cosmos. After the collision and settling, the two galaxies will have become one larger galaxy. Gamma ray bursts. There are all types of events throughout the galaxy that give off different types of energy. One of the most powerful types of energy that can be produced in our universe comes in the form of gamma ray bursts. Events that give these energetic bursts off are some of the most powerful and destructive events in our universe. They include supernovas, black holes, and a few other theoretical sources. When a star goes supernova, it generates a large blast of energy that is emitted as a gamma ray burst that spreads out from the star into space. Once the bursts are into space, they will travel at the speed of light until they run into something. If Earth is unlucky enough to be in the path of a strong gamma ray burst, we can expect to deal with some difficulties on our planet. A burst strong enough can knock out the electronics that control our satellites, as well as take out much of the electrical systems on Earth. The sun will expand as it dies. One of the more dire discoveries for Earth that astronomers have made has to do with our own sun. Our sun is currently classified as a yellow dwarf star. It does not have enough mass to go supernova at the end of its life, but that doesn't mean it'll just go out. When our sun begins to die, it will begin to slowly expand out until it becomes a red giant. When it expands, it'll get close enough to Earth that it will scorch the Earth, evaporating all of our surface water and killing much of the life here. It may even get so big that it engulfs the Earth as it expands. But don't worry, this is not going to happen for at least another 7 billion years, so we have time to make a plan for our escape. Planet made of ice is on fire. There are many planets out in the cosmos. Did you know that astronomers found a planet that is both made of solid ice and is burning at temperatures over 800 degrees Fahrenheit? It's called Gliese 436b and is a Neptune-sized planet discovered in 2004. Gliese 436b has the unique properties of having a surface made of solid ice while having surface temperatures above 800 degrees Fahrenheit. Astronomers believe that this is possible due to the immense gravity from the core of the planet, which causes the ice to be under so much pressure that it cannot melt. The surface is also covered in a layer of hydrogen and helium gas, which acts as another insulator keeping the balance between fire and ice. Dark matter. Everything that humans have ever seen makes up only about 15% of the matter that makes up our universe. Scientists have named the other 85% dark matter because it does not interact with light, making it invisible to our eyes, and does not interact with ordinary matter outside of its gravitational pull. Astronomers know that dark matter is out there because its gravitational effects can be seen throughout the universe, affecting giant clusters with its gravitational pull. While they don't know what dark matter is, there is no shortage of theories taking a shot at the answer. Dark matter has been theorized to be made up of dark bosons, which form invisible ghost stars that float throughout space, not interacting with any matter that it touches. Another theory states that dark matter could be made up of trillions upon trillions of subatomic particles that are just too small for us to see, like neutrinos. But until scientists know what dark matter is, they will have to keep observing its effects and trying to study it more. There are so many fascinating things to discover in our universe, and astronomers keep finding new objects and events that keep giving them a deeper understanding of the universe we all live in. We want to say thank you for watching, and if you enjoyed this video, please feel free to hit the like and subscribe buttons so you won't miss any of our future videos. Every star you see in the sky is really another sun, an enormous orb of burning gas drifting through space, untold trillions of miles away. Each one is only one of hundreds of billions of stars in our Milky Way galaxy alone. But not every star is created equal. Some are very much like our own sun, potentially harboring planets teeming with life. But some are so unusual that they would appear completely alien to us. This is matter, and these are some of the strangest stars ever discovered in our universe. Number 10. Stephenson 218. The star Stephenson 218 is part of an open star cluster, 20,000 light-years away. This star holds the distinction of being the largest star discovered to date. This enormous star measures in at an incredible 2,150 times the diameter of our Sun, 930 million miles from one side to the other. If Stephenson 218 were placed at the center of our solar system, it would engulf every planet up to and including Saturn. This star is classified as a red hypergiant and is larger and more luminous than astronomers had previously thought was even possible. Stephenson 218 is so large that its own gravity is likely unable to hold on to the upper layers of its atmosphere, causing the star to constantly lose mass over time as it is blown away by the solar wind. Number 9. Vega. Vega is an extremely bright, extremely hot star 25 light-years away. The fifth brightest star in the night sky and the brightest star in the constellation Lyra. Vega is around twice the mass of the Sun and 40 times more luminous. But the strange thing about Vega is not its size or its mass, but its rotation. Like the Earth, which rotates on its axis once every 24 hours, the Sun also spins with a rotational period of 27 days. Vega, on the other hand, makes a complete rotation every 12.5 hours, ridiculously fast for any star, let alone one as large as Vega. This rapid rotation causes the entire star to flatten out, bulging visibly at the equator as the centrifugal forces push the star's mass outwards. At the surface of Vega, the speed of rotation is 236 kilometers per second. Given Vega's size and mass, that is 88% of the velocity required for the centrifugal effects to tear the star apart. This rotation-induced flattening of Vega also leads to another curious phenomenon, known as gravity darkening. Its oblong shape makes the regions near the star's equator significantly cooler and dimmer than the poles. Number 8. WR102. WR102 is classified as a Wolf-Rayet star. These stars are characterized by their relatively faint hydrogen signatures, but strong signatures of heavy metals, such as iron and nickel. Wolf-Rayet stars are rare enough, but WR102 is even more unusual. This star's spectra contain unusually high concentration of ionized carbon and oxygen. It is only one of 4 known Wolf-Rayet stars in the Milky Way with a similar spectrum. WR102 is also very dense compared to a typical star. It contains 16 times the mass of our Sun and yet is only half as wide. Much of WR102's mass has been ripped away by its powerful solar winds, and the debris now surrounds the star in a nebulous cloud of gas and dust. The star is continually losing mass at an estimated rate of 3 Earth's worth in a single year. Because WR102 is so dense, it burns unimaginably hot. The surface of WR102 is 380,000 degrees Fahrenheit, or 210,000 degrees Celsius. That is 40 times hotter than our own Sun and makes WR102 the hottest star currently known. Number 7. Kapteyn Star. Captain Star is 12.8 light-years from Earth. It is a very small, M-class red dwarf, only 30% of the mass of the Sun. These red dwarf stars are extremely abundant, comprising around 75% of the stars in the Milky Way. The Captain Star itself is an anomaly. Most of the 400 billion stars in the Milky Way orbit around the same galactic center in more or less the same direction, similar to how all the planets in the solar system orbit the Sun the same way. Captain Star, on the other hand, has a retrograde orbit. Its path around the galaxy goes in the opposite direction from most everyone else. It is theorized that Captain Star was once a part of a small dwarf galaxy that merged with the Milky Way billions of years ago, tossing the star into its odd, backwards orbit. Number 6. Tabby Star. Tabby Star is a hot, F-type star located 1,470 light-years from Earth. It is about 1.5 times larger than our own Sun. Tabby Star was one of several 100,000 that were observed by the Kepler Space Telescope. Kepler's mission was to watch these stars for any fluctuations in brightness which might indicate that an exoplanet is briefly passing in front of it. Typically, the measured dip in brightness caused by a transiting planet is only a small fraction of a percent of the star's total brightness. However, Tabby Star has been observed to dim by as much as 22%. There is no way for an orbiting planet to create such a deep transit. Whatever it is, it would have to be covering at least half of the entire width of the star. The periodic dimming of Tabby Star also appears to be mostly random, unlike a typical transiting exoplanet. Why Tabby Star almost seems to switch off at times is still unknown. Some hypotheses include an uneven ring of dust, a swarm of cold, icy comets, or perhaps a planet or orphan moon being torn apart. The idea has even been thrown around that it might actually be due to some sort of alien megastructure, such as a Dyson swarm. But there is little evidence to support this particular notion. Number 5. S5HV S1. S5 designation refers to its classification as a hyper